Excellent. We are now recording to the cloud, the entire cloud. Lesson 4, functions. How's it going so far? How's it feel? Everybody feel pretty good with functions so far? Getting your feet wet a little bit, getting some logic, realizing that it's just a container for your logic that you could reuse and call on after you declare it. That's a huge realization. It really is. Like, I'm not joking. I showed some people at work actually yesterday some functions, and I got to make their code a little cleaner, and their minds were melting. They were blown away that they could reuse it. They don't have to cut and paste it, or it's amazing. It helps. A little design helps, right? And later when we talk about classes and objects, like in the next lesson and in lesson 7 and 8, you'll realize that there's types of objects, like I've been showing all along with the type command. And those type of objects, like here, I'll just light one up, right? Let me pull up a shell real quick. Types of objects matter. And what do I mean by that? Well, let's just do var1 equals, I'll throw a string in it. You do a type on var1, and it tells you that the class of object that you're working with inside of var1 is a string. So what does that give you? Well, that gives you all the methods, the functions of that class. Functions of a class are known as methods. Lower, upper, capital, title, split, join. All these things you can do to this var1. Like if I do var1 dot and say upper, open, close, and hit enter, you see that it takes all the small lowercase and makes it all capital. You notice I didn't use capital, I used upper, right? Now, the wild thing about it is it's just a method. It didn't change what's inside my variable. It didn't change the object inside my variable. When I called my variable, it applied the upper method or function to that string type and then displayed it as upper. You can't upper an integer, right? Like if I had a var2 equals 3, and I did var2 dot upper, you can't do upper to an integer because it's a different type of object. So the objects matter, the types matter. There's classes for certain objects, and within those classes, there's functions. They're the same thing, but we call them methods of the class. Does that make sense? Kind of couple lessons ahead, but I want to talk about it because it makes sense, like why you're making functions now, because you learn how to make functions, then later you learn how to make a class, and when you define methods in a class, it's the same thing. It literally is def and a name, like a function. Isn't that cool? I think it's cool. I think it's super cool, right? Super cool stuff. And functions are awesome. So let's see these. What do we got to do? We got some group lessons. Let's zoom in a little. We got write a program which simulates rolling dice. Dice or die, or both. I don't know. It should display the random number rolled. Okay, so we'll use the random module. We'll import that. Ask the user if they want to roll again. That's pretty huge. If they don't want to roll again, the program should end. If they do want to roll again, the new number should display. Okay. At a minimum, the die should have 6 sides, but that's easy to change. 12 or 20 is fine too. Okay. And the next one is just a math program. Randomly generates some numbers, adds them together, and then asks if you want to play again. We could do that. Want to create some dice? Anybody feel like making some dice? We could start off with this. Let's make some dice. This will be fun. So let's see. This is class. We got the entire class here. This is lesson 4. This is, well, I'll just say group lab. Perfect. File save. Oop. I'll dump it in less than 4 so I know where it's at, right? Good hygiene. Boop, saved. So we gotta do some dice. All right. So let's think about this. Let's get something working first, and then we can always come back and trick it out, right? So we can do a couple things here. Does anybody have any thoughts on how you want to start off with the dice? We know we need to get some random stuff. So we'll import random. Remember, this imports the entire module and not just what we need. So let's import it over here and do a dir on random. Oop, what'd I do? Oh yeah, dir space. Sorry, I've been using a different language all day. There we go. And let's see what we got here. We got choices. We got a random integer. That sounds like what we'll use. So instead of importing the entire module, we'll just, you can do this. There's nothing wrong with importing that. But you could say from random import and then just what you want, rand int. Now we could do something even cooler. We could say import rand int as rint. So now I can hit save, press F5, it runs, hit enter to close, we're good to go. So you could actually shorten the commands too. So from the module random, I imported this guy right here, rand int, and then I gave it an alias and I just called it rent. Cool. So now it's less typing for me. I don't have to type rand int. I don't have to type random.randint. I can just call in rent. That's helpful. Less typing is always more expedient, right? Well, we know we're going to have a main function. We know all that, but first, let's get our dice rolling, right? There's two different methods. There's bottom up and well, bottom up and top down and down up, whichever way you want to say it, of design. You could build your function now, attempt to define your function and build everything, or you could build the inside and then just build your function around it. We'll flip it. We'll do one each way, right? So we know we have dice. Well, in reality, we just need one die behind the scenes, and we could roll it twice and add those two together, right? That would be pretty easy. If we have one dice or die, and I actually had to look it up. Webster's dictionary changed the definition of die and dice. Dice could mean just one die. Doesn't have to be plural. Isn't that weird? But anyway, they changed it. So you could bring back some oldies and goodies here too, right? 4 each dice in my range of stopping at 1. What will that allow me to do? That'll let me loop once. Well, if I'm going to loop once, I need 2 random rolls. 1 through 6. Yeah, it's coming up. It's coming up, Eli. I was going to tuck it under my 4. Control it with a for loop, and then I'm pretty much going to cut and paste yours. Instead of dice, I'm going to call it roll. Roll 1 equals exactly what you have. It's going to be random int 1 through 6. Instead of I import as rent, so I'm just going to say rent and 1 through 6. Does 1 through 6 work, or do we have to stop at 7? 6-sided die. If it I never saw a dice with 0 with nothing as 1, 2, 3, 4, 5, and 6. So technically it's 1 through 7, right? I mean, it still work with 1 through 6, but we'll just roll with we'll roll with it. Get it? And we'll change this to roll 2. So now we have roll 1 and roll 2, which are nothing more than random integers between 1 and 6. That's it. So to get our total, we just literally total equals roll 1 plus roll 2. Now you're probably saying, why'd you do it individually? Well, it allows you to manipulate your roll 1 and roll 2 objects and your total. So what you get here is you get the ability to say print f. You can say things like print you rolled curly braces roll 1 and roll 2. And you could say for a total of total. Right? It's pretty cool. Let's run this. We'll see what's up. You rolled a 2 and a 1 for a total of 3. Press enter to close. I'm going to comment that out just for now. So it feels like we got things going, right? Cool. How would I put this in a function? Any takers? I want to make this repeat over and over and over again. Or do you want to finish the play again logic? You want to do that? We could totally finish the play again logic, right? So here's our for loop, right? When this is done, when this logic's complete, it's going to stop. So we're back all the way to the left to the side. And if we say, get some input from the user, if we ask them, do you want to play again? And we could call it play again and equals, and this is input. This is where you guide the user. Would you like to roll again? Question mark, enter yes, comma, n, colon, right? We'll give it a slash tab to make it all pretty. So now we got, would you like to roll again? And now we could use our if-else statements. If play again is equal to yes or y, or play again is equal to little y. Now this is where we have to roll again. Now this is where your function comes into play, right? Let's finish this out. We'll say roll again. Give it our else, if else statement. And else you could just print thanks for playing. Adios. Right? Change this, delete a, change that to a capital T. Cool. Now here's where we need our function, roll again function, or play again, or run the whole thing again. So this is a design question we got going on now. So up top, you go define, we'll call it roll dice. roll dice, no parameters. We'll grab our our role plane, tab it over. So now this for loop is a part of this function. This is our definition. This is our script statements underneath roll dice. This is back in global space here. This is all local, right? And we got our play again. Well, in reality, we could define play again, tab this over. And now play again would call on roll dice. And now what we can really do is go back up top. I like to put my main function up top. Main, open, close. And what we could do is call on roll dice. So roll dice will fire. Well, let's run main first, right? So if we call on main, it will call on roll dice. We'll roll dice, but roll dice tells me what I played. Now we have a design choice here. We could put play, we'll call play again, play again. We could put play again in roll dice, a little sloppy. We built a main function for a reason. You could put roll dice and then play again. So in theory, we'll call on main, it'll call on roll dice, it'll run this. When it's done, it'll ask you to play again. If you select yes, it'll roll dice again. It won't go back to main, it'll roll dice again. Everybody following that flow? Does everybody remember what this does? Anybody read up on this or catch it in your book? And there's where we call on main. See it'll work? What can we add to this? Do anybody want to add anything cool or add anything? Because we're going to. We could add some cool stuff, but let's save it. Let's run it, see how it goes. You rolled a 3 and a 2 for a total of 5. Would you like to roll again? Yes. You rolled a 4 and a 7 for a total of 11. Well, that's a problem. Yeah, mainline logic. Well, that's a problem, right? Because we called on main, rolled our dice, played once, played again, asked if we want to play again. It rolled dice, and that's it. It didn't ask us again. Well, now becomes the choice, the decision of going, hey, this worked up here. It was cool, but only fired once. So we're going to cut it. We're going to put it right there. So now, main line, roll dice. It's going to give us our answers. That's going to call on play again. If you choose yes, it'll call on roll dice. It'll fire play again. If you choose yes, it'll roll your dice. See, now you got your functions operating optimally, maybe. Save F5. You rolled a 3 and 7 for a total of 10. Would you like to roll again? Yes. Oh, now we got asked again because the logic is there, the flow control. Total of 8. Like to play again? Yes, 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 yes. No. Thanks for playing. Adios. It exits clean. Awesome. What do you think? Anybody have any comments? Any questions? Any points of interest?
Yes. When you start, it automatically starts with a roll. So maybe we have data to introduce the rolling dice.
Love it. Lemonized roller game, right? Yeah. They'll say, I'm thinking a different language here. My bad. Name equals input. What is your first name? Question mark / tab quote close. Already closed it. And now we could get really funky with this, right? So now, welcome to the rolling dice game. Got a nice intro. What is your first name? Cool. Now I could say, do you want to play? Right? Think of that. Do you want to play, right? Now you're like, okay, do we want to go there yet? Well, not. Well, we won't. Let's do this. Well, let's return name and roll dice. We'll give it a parameter now. We'll give it a X. We'll give it just an X placeholder. And down here, you rolled blah, blah, blah. Instead of U, let's call on X. So in theory, check this out now. This is cool. Get name, right? Welcome. Enter your input. Return name. Roll the dice X. How would I pass name to roll the dice? Would I just swap out roll the dice with name? Pretty cool. So now we have the get name function, roll dice, play again. A couple things we could do here. We could run get name first, then it'll roll the dice and see how this rolls. Welcome to the dice roller game. What's your first name? Timmy. Oh, we got an error. What happened here? Line 15 broke. Missing one positional argument, name. Well, right here we didn't do it, did we? So this could be X, and this could be X, but when we call on roll dice, we need name. Roll dice, name. Let's see if that fixes it, right? Oh, name is not defined. Line 15. Line 15 is where? Right here. So how do we deal with this? We got get name. We hit enter. How do we overcome this? Do we need a get name function? Can we put it in main and then pass it in our local functions here? You notice this is how most people think first. We think we need to define something, then return it. But once we return it, we need to store it somewhere. Get name returns name. So we could simply call it first name equals get name will run, give you your welcome, ask you your name, store it in name, return name to first name. And then we could use the first name variable in roll dice and first name. And now first name holds the return name from get name, and then it replaces X in roll dice. Is that clear as mud? Let's see it fire once. I'm going to close this. I'm going to run a fresh shell. I'm going to hit F5 to run it. Okay, save that sucker. Welcome to Dice Roller Game. Okay, so in logic, this is in memory, all in memory. I called on main. Main called on get name. We are right here in this code. What's your name? Timmy. I hit enter. Timmy is passed to name. Name is returned and stored in first name. Timmy's in first name. Roll dice, Timmy. Roll dice, Timmy. Roll dice does its thing. It replaces X with first name. So now I have Timmy rolled a blah, 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 blah. Would you like to play again? Well, check this out. Would you like to play again? How would I put Timmy's name and play again?
You could do it in the print statement, or you just put X and play again.
Now, if I put X and play again doesn't take an attribute or a parameter. So now I have to update this. We'll just call it FN for first name. And then it'll go ahead and play again, right? Now I could do input is here. Can you call on variables and input? Anybody have any luck with that? We'll give it a shot. Would you like to roll again, comma, and then how would I call on, well, this has to end, right? Not comma, quote, comma, and then I call on FN, right? So in theory, FN should be replaced by X. X is Timmy. It should all go in a big circle. Let me cancel this. Let's save it. Let's run it. Timmy. Oh, trace backs all over the place. Oh no, line 36, line 15. So line 15, mainline logic, first name broke. Roll dice, first name. Well, why? Why'd that break? It took it because we see Timmy was cool. Timmy went to roll dice. It printed my Timmy. And then when I say play again, Timmy, what happened? Did it really pass Timmy to FN? Now, this is where you start looking at your line numbers. And you go, okay, let's take a look at this. Would you like to roll again? Input expected at most one argument got 3. So is it better for me to comment this out and call on play again first name? I'm walking you through the logic here because this does happen, right? So now instead of calling on play again from roll dice, I'm going to give me your name, roll the dice, play again, and then we'll see where we go from there. I'm going to hit save. Let's get rid of that red. Let's open up a new shell. Always on my different screen. It bothers me. Save F5. What's your name? Timmy. Okay, we're still broken here. Would you like to roll again, FN? So it didn't like this at all. So does it have anything to do with how we designed it, or is it our input statement? Let's fix this. Let's do a print statement. And we'll just say, let's do F statement, quote, FN. Would you like to play again? Question mark. Now that's just a statement. And now we could do this. Gather input, right? So let's go back to this whole thing and see if this really did work. And it was just our input statement jacking us up with that variable. Save F5. Timmy, you rolled a 5 and a 4 for a total of 9. This is Timmy right here. And then it passed to play again. And now play again used Timmy. Timmy, would you like to play again? And now we're down to yes or no. We'll say yes. Oh, my bad. I added another backslash. Let's rerun it. Let's stick with Timmy. Would you like to play again? Yes. Ooh, trace backs out the wazoo. So now we got, would you like to play again? Yes. Roll dice. But now I'm missing a function, or I'm missing a parameter, which I could simply just pass it FN. Right? First name. Let's see if that did the trick. Timmy. Yes. Oh, it still kept Timmy. Now, the flow of this script is getting pretty complex for a pretty simplistic thing, right? You notice it didn't prompt me again for what my name is. Good. Once you have it, right? First name, get name. We never run get name again. After we get name and we store our name, in our next two functions, we pass that name value around. Could we make it simple and just call everything first name instead of X and FN? Or use FN everywhere? Yeah, they're local scope, right? So you could be like, yeah, first name here, but everything you call an X has to be first name. This is called refactoring. You go back, clean some stuff up. So now this FN just belongs to roll dice. This first name just belongs to play again. They're in their scope, so they won't cross, right? And they're just arguments. It's just a placeholder for a parameter. So then we pass it our parameter of get name, first name, and it should work as designed again. Let's give it a try. Welcome, what's your name? We'll say Liam. We'll say yes. Never ask us again. I'll say yes. I'll say yes. I'll say yes. I'll say yes. Okay, it's proof it works. Say no. Then it breaks. This is completely reusable. I think it's overdone, but I like it. Right? Flex. This is what we're here for. The important thing is there's a lot of debate if this is still needed. It saves you from yourself. It checks in Python's memory that your script name is loaded into the main space memory, so what you're about to run is available. If name double underscore built-in name currently running is equal to the main logic of your current running script, then run your main function. You can just tab or comment this out and pull this over and run main. It'll be fine. This check is there to benefit you. It's a little pro tip. There's a lot of deep ideas and good reading all over the internet on if you should have it, shouldn't have it. I use it as a hobby, as a habit, I should say, as a habit. It's good practice. It's best practice, right? Building the main function, pretty good practice. People will call this game and then build parts of their game and roll the parts up of their game into game and then run their game. Fine. That's fine. But another scripter to another programmer to another, when you open up this script, you instantly know main is their main firing. If it's called main, you know it's your main logic source. You know it's going to call on everything else. There's no question. Can you have functions call on functions? Yes. Can you define functions within functions? Yes. You can get as tricky as you want. But right now, this is pretty tricky. Let's get rid of that red so it's clean, right? But you see where we came from. I think best practice is 2 spaces between functions. Yeah. That'll be fine. What do you think? What do you think so far? Digging it? Pretty cool? Quiet group this evening. Functions usually do get you. Plus, it's, you know, you guys have like midterms and stuff, and it's a tiring week. It is. I mean, nothing's really wrong if you delete all these functions and tuck it all under main and just call on main. It's still a function, but you lose a little bit. And I'll show you what you lose. You lose being able to borrow that and rebuild new stuff. I'll just grab this. That's a lab. Where's my... Always losing my template. Telling you. There we go. So you lose the ability to either call on it or steal it and dump it somewhere else. Well, let's take a look at our second group activity. Write a program which gives easy math quiz. 2 random numbers adds together like this. Okay, so formatting will be the son of a gun. Now listen, this sounds a lot like the requirements from the other script. Program should ask the user to enter their answer. If the answer is correct, they should be congratulated. If the answer is wrong, the right answer should be displayed and the user should be scolded. Don't forget to generate random numbers and ask if the user wants to be tested again. Okay, play again. We already wrote that. Right? Let's just write it. Ooh, I like this. Welcome. We'll do this. Welcome to the math quiz. Right? Kick butt. Love it. Line break, define main. We'll keep that. Script body. I'll comment this out for now. And we'll leave that here. We'll undo this. We'll just say pass for now because we don't know what we're doing. Plus, we didn't call on it yet. I like this. We'll deal with this. We'll take that. Put our random imports up top. Cool. Let's play again. Let's get name. Cool. So we got name. We're going to play again. Let's define some math, right? So what's the coolest way to do this? Could we steal what we just did and rename a whole bunch of stuff? Totally. It's pretty much the same thing, except we're not going to call roll the dice. We'll put it right here. Give ourselves our 2 spaces so it looks legible. And we'll say, we want to call this math quiz. Perfect. Love it. So you can have it do parameters and guess stuff. You can have it generate the random numbers outbound and then pass it to it. We'll talk about that. But now let's talk about for test in range of 1. I'm going to do 1 test at a time. That's fine. Or you could use a while loop. I always use 4s, but that's just my style. Instead of roll 1, let's say add-in. Is it called an add-in when you add to each thing in addition is called an add-in, I believe. We'll just say add. Add 2. Let's see, the integers have to be from, we'll say start at 1 and go to stop at 600. So now we got 1 to 599. I'll just cut and paste that. Didn't need to grab the 1. But now we got our add 1 and add 2. You rolled. Okay, we didn't really roll, right? Let's just say blank. Let's see. First number and comma second number for a total of total. Okay. That might get us started. Let's comment that out. So this is going to need us for first name. Math quiz, right? So the fun thing is we could just do this. Get name. We'll call on get name. Get name will return name. We need to put it in something. So we'll just do first name again. First name equals get name. So we run get name and gather to be name. Name will be in first name. And now we'll call on our math quiz. And right here, we could pass it, you guessed it, first name. And that should be fine for now. Play again will be put in memory, but not ran. And play again's commented out. So we're just going to start to test this. Let me move that over to here. But that wasn't too bad. We were able to reuse a lot of code, right? File, save as. We'll go, I don't even know where I'm at. Lesson 4. We'll say, yeah, group lab 2. Good enough for now. So let's run it. F5. Welcome to the math quiz. How come nothing happened? What happened?
You're missing your if main or if name equals main, call on main.
You're right. But how did welcome to the math quiz get printed? Oh, it printed outside in global scope, right? Exactly. So you're going to make these mistakes. I want you to see them firsthand, just so you're not taken off guard by them, but you're kind of used to seeing them. And now let's call on our main. So now this is going to print the screen. This will be defined. This will be defined. This will be defined. This will be defined. This will be checked. This statement will run. If it's true, it'll run main, which will run our get name. It'll store the output of name in first name. Then math quiz will run with first name as FN. Should do the test. And should tell us what we rolled.
Can you change the role to add?
Where at? Did I already do that?
Your print statement here, first number, and then you've got your
Second number.
squiggly marks, roll 1 and then roll 2.
Ah,
See it?
good one. Yeah. Well, let's see what happened. Probably nothing, right? Let's see it. Let's break it. Boom, right? Because they're not defined. The error message is not defined. You guys caught it early, but you're totally right. Add 1. Add 2. Save F5. What's your first name? Oh, got to be in the window. Type that anywhere? No, good. Timmy, your first number is this. Your second number is that. Total of that. Awesome. Not ideal. It doesn't look right. It doesn't look how they want on top of each other with the addition sign. So let's get that going. Let's get rid of the F. Let's get rid of Timmy's name because that'll just drive us crazy. We have our first number, but let's go old school, right? And we'll do it old school and we might try it new school. Let's see what's happening here. So we know we have this and this for a total. We know that that'll print out the first random number. This will be the second. This will be the value, right? The total value, but it's not horizontal. Could you do 3 separate print statements? Yes, you can waste your time lining them up and having a good time, but let's think about this.
New line.
Yeah. After your first variable, you're gonna
New line.
do a new line. You're right. Comma, right? Well, let me get rid of that pipe and actually put it when it's. So now this should add 1 should print, then a hard return. It should print your add 2, right? But in front of add 2, you want to have your plus sign, right? So let's throw a plus sign in here and a comma. We're not going to do a hard return. Print's basic separator is a space. So you have one space after the plus sign to your 3 or up to 3 integers. And now you have your add 2, which needs to be followed by yet another new line, right? And then you have something bizarre, which is you need a line, right? So you could pull this off in one print statement, but we'll give this a try. And we'll say, okay, comma, quote, just do a bunch of dashes. I think dashes will work. I don't know how many. We'll start with that. And we'll see how this looks, right? It's not going to be perfect your first time. It might be. So what's your name? Timmy. All right, little janky here, but how could you fix this? Could you go, let's see, that's a couple over. That's about 3, quote, 1, 2, 3, quote, comma. That's where you save that, rerun it. That's 1 too many, right? It may be wrong depending on if it's 2 or 3 too, right? So you're gonna have to mess with this. Cool. We're getting there. This total I don't like. Could you do another new line? Good enough. It's getting there. It's not perfect. It looks kind of sloppy. And here comes our 2 digits. So now it's like, is one line really smart? We start thinking bizarre, right? Can I really do this in one line? Yeah, you can. It'll drive you crazy. You'll beat your head against the wall. Let's see, but you don't want to give them the total. You want to ask them for an answer. Goodbye. So now this will print out sort of okay. And now we want to ask them for an answer right there. So now here's where, after the print statement, we ask them for the user input. User in, or we call it answer, right? We can say input, integer, input, and then another one. And then what do we do?
Please answer the question. And then underneath that, I'm guessing we would do whether or not the answer matches or the total matches the input.
Totally. I like that. Let's see how this rolls.
But I just
Okay.
thought of
Yeah.
their answer is going to be a string. Oh, never mind. It's going to be in it.
But you see how you type and it goes that way? That's okay for now. In the future, lesson coming up, we'll learn how to type the opposite way. But for now, bear with this. Do the math in your head. 9, 7, carry the 1, 7, 7, 9, right? Hit enter. Works as designed so far. Now we got our answer in here. Now you were talking about the if statement, right?
Yeah. So if answer is equal to total, print out U1, and then else if what the if answer is not equal to total, you suck. No.
A little drastic. You're correct, right? Then you got, what's the other one? Else. Else is good,
Yeah,
right?
you can just do else print. You don't have to do another
Gotcha.
Uh,
Print, you are incorrect. Incorrect, period, quote, comma. You just say the correct answer is, and what was that? What was it? Total. Okay. So in theory, this should work fine, right? Else for you one correct. We could, of course, we could always swap out you for FN, personalize it, make it Timmy, all this fun stuff. Let's see. First name, Timmy. Okay, here we go. 2, carry the 1, 9, 391, right? You're incorrect. The answer is 392. Why'd I do that? Just to break it, right? Cool. I want to play again. It's time to play again. What do you say? We ready to play again? And this is where you can get tricky and say, input, we could say, play again. What do we do for play again? We could do PA for play again equals input. Would you like to play again? Question mark. And then you could do the y/n. All right. And then :/tab, give it some room. And now you can get tricky again. Nested if statement. If PA is equal to yes, or, let's say or, right? Or PA equal to capital Y, then we play again. Else, print. Thanks for playing.
Doesn't our play again
Does
segment them?
Does it? Does it do it for us? Yeah, it does, right? Thanks for playing. So, check this out. This rolls dice. Right? So we stole code. Roll dice really isn't this. So now you caught it, right? We're duplicating code. We don't need any of this. All we need is simply, you were incorrect. Would you like to play again? Play again. Do we even need this? Could we just say, play again? This is the power of functions. Would you like to play again? Don't even need that. Look how clean this code is becoming. Even if you're correct, play again. And now we go down to play again, because now instead of asking all those questions again and looping yourself and messing up your code, you already wrote a play again function. Right? You guys caught on to it halfway through it. You saw me recoding and you're like, yeah, that don't even look right. You're right, because it's not. Functions allow you to use, yeah, you could do that and not equal to. We'll take a look at that. Not equal to what? Oh, totally. I'll clear this shell, Steve. Sorry about that. We'll just do a new one. My bad. I had the chat on another window. I apologize. Boop. So now we got our play again function do all the heavy lifting for us. You won, play again. Would you like to play again? Yes or no? It's already done. Thanks for playing. Adios. Except this is the problem, right? We just need to change that to math Q. In theory, right now, we got a fully operational battle station in theory, right? Let's walk through the logic. Define main, get your first name function, store it in first name, math quiz, use the first name. That gets stored in memory, doesn't run yet. Get name, stored in memory, math quiz, stored in memory, play again, stored in memory. Our operator validation, we're good to go. If that's true, it'll run main. Main will call on, well, define first name, which will call on get name. Get name will ask you for your name, return it, and store it in first name. Math quiz will run using your first name. Math quiz first name. It'll do your test, and it should be good. Prompt you for your name where FN is. If you get it right, you're correct. Play again. If you're wrong, play again. Okay, I like where this is going. First name, Timmy. Okay, what we got? 79697. You won. You're correct. Would you like to play again? Cool. Timmy, personal. I'm gonna say, yeah, sure. Okay, this one. 29892. I'm gonna say no here. You know what? Let's get one wrong. We'll say yes. You're incorrect. That's the correct answer. 769. That displays. That's one of our requirements. Would you like to play again? No. Thanks for playing. Exit's clean. Pretty awesome. We changed a couple things. We borrowed a lot of that code. We caught ourselves from writing more code because we already wrote it and play again. Reutilizing logic is awesome. The first script took us a hot minute to write. The second one took us a couple minutes just to get there. It took us longer to format our addition, which still isn't perfect, but we'll take it. It took us longer to format the addition than to do most of the logic. And that's the point of these group exercises, is for you to really sit here and ponder, what pontificate if you must. Like sit there and go, man, like functions really do make life easier. Totally. Now, if you didn't have to change anything, and if these were written pretty generic, you'll learn how to write generic functions that work everywhere over time. If you decided to just call this game, and it wouldn't matter if it's dice or math or race cars or whatever, you could just call on play again from this file, import from 2252 class L4 group lab pi, import from that file name, and then you, just like we did randint, from that file name, import play again, and you can import as PA or just leave this play again. So you can import other functions from other files too. Awesome if you have all the files. I don't have all your files in this class, so for this class, write all your functions in one file. Keeps it clean, right? But in lesson 7, we're going to revisit that concept. And that's pretty much it. Now, think how powerful this is. You learned how to gather input and print stuff to a screen our first week. Awesome. First lesson. Second lesson, you learned some if, else, elif, and else logic, like comparison operators. Third lesson, it was all about loops, right? While loops, for loops. For each object in my group of objects, perform this task. While this condition is met, perform this task. You can simply change your for loop to a while loop and have your play again run on a while loop. Play again equal true. No, not just while true, play again equal true, while play again equal true. And you can change your output there to flip your loop. You can do all kinds of fun stuff. The design is up to you. You can make it as complex as you want. You can make it as easy as you need. But from here on out, every script is going to have at least two custom functions. So from now until the end of the semester, your next, 5 lessons to include your final will have custom functions. The more you use them, the easier they get. The more you design your code, the more you think about your code, the more you don't have to compartmentalize your code this much. This seriously could have been define main, all the code, and then just if name equal main, run. You could do that. But what you lose you lose the ability to cut and paste other functions, call on other functions, and reutilize code somewhere else. You lose all that because you just coded it from top to bottom, and you really can't move it anywhere. It's not reusable, right? But this, in all instances, it's reusable. We create a couple of fruitful functions, in other words, that return something. Let's talk about counters. If you wanted to count how many times you played, I'd create a global variable called counter, or wins, losses, ties, whatever. It sounds like Rochambeau, right? Or RPS. You could add those counters globally, call on them in your main function, and if answered total you won, you could do this. If we had a counter named 1, you could do 1 plus equals 1 plus 1, or just 1, right? Because it'll add 1 to 1. So every time when you win, your global counter will go up 1. And if you lost, gotta do it before play again. Gotta do it before play again. You don't really have to, but it's just good practice, right? So if you lost, losses plus equal 1, right? Then you could define up here your global variables. Win, I call it 1. 1 equals 0. Loss equals 0. And then if you want to, when you're done, you could print them out either after main, or make another function to print them out. You could do whatever you want. You could have another one called ties, if there was such a thing, right? I'm setting you up for RPS, by the way. So, and then you can either just print them out here, print f string u1 blank times 1 times. Let's see if this works. Is it gonna work? Anybody think it'll work? Timmy, let's see. You got 8222228. Enter. Oh, what happened? Local variable 1. How do I make this my global?
Inside the function, you could do above 1, put global 1.
I'd have to do the same for losses, correct?
Correct.
Just rerun it. Let's do, is that 448, right? You're correct. No, thanks for playing. You won 1 times. Works like a boss. This is the power of declaring global variables and then loading them into your local. Well, it's still global, but you pulls in your 1 as a global variable, updates it, and then restores it with the updated amount in global space. So now you could reutilize these functions anywhere or those variables anywhere you want in your code. And simply, we just said print how many times you won, right? You can also cut and paste that, how many losses, how many ties, things like that. Isn't that awesome? What do you think? Super cool. Think of this logic, though. Think of gather a machine name, get a machine name. For each machine in my machine, do something. If it comes back correct, tell me you're correct and how many times you did it. You could do this for machines, usernames, checking files, looking for. You could do countless. Same type of theory, same type of concept, different object types. That's all it is. Different object types. Don't ever be afraid to code. If it fails, just understand what objects you're using. Strings, integers, custom objects. It's fun. It's a lot of fun. So what do you think so far? Eli. Think of rock, paper, scissors. Let's talk about your individual lab now. Do you want to play? Yes or no? While playing equals yes, perform these functions. And it's okay to put a while loop under your main. You can put a while loop. While play equals true, do this, and break your loop by asking, do you want to play? And you say no. So while play equals no breaks, it fails. It's not yes, right? But you could do things like that. You could definitely write a main function. That's best practice. You could do a get name if you want. It's up to you. Of course, you're going to have your RPS. You're going to have also your random selector for your computer, that value. You're going to compare those two. You're going to have at least 4 counters. You're going to have wins, losses, ties, something like total plays, something like that. It's up to you. Total rounds, whatever, right? And that could be a total of all these, total of wins, losses, and ties, so you don't have to calculate that. You can just do 1 plus loss plus ties, and now you have your total plays. It's pretty cool. Let's get back to the concept. Random choice by computer, random choice. Let's take a look. Import all of random. Dir on random. It has something here called choice. It might help, right? Well, random integer looks a lot like a range, but it doesn't stop at before 600. It actually includes 600. Random integer is not the same as range. This is not a start and stop. This is a start and okay, we'll stop here. It's not stop before. It's a little different. Written by different people. It's an open source language. Don't get mad, right? It's free. Free 99. Don't get upset. When you start looking at this stuff, you learn the nuances of it, and each module is written differently. So, a little bit. It follows the same general overtone, but some things are mildly different. Think of this. When you ask someone to play rock, paper, scissors, and could rock be 1 on the back end and paper be 2 and scissors be 3 or whatever you want, change it to an integer. So instead of comparing strings, you're going 1 equal to 1. If chose rock equals 1. If 1 equals 1, random choice 1, then tie. Is that easier to follow in your brain than going, is rock? Is rock equal to scissors? Could you give them numerical values and determine on your own? It's not by being numeric if they win or not, but by the value you give them. Could you code that? Take a little bit of concepts from our color mixer, everything we've learned up till now, and turn that into like a cool rock, paper, scissors game? Yeah. I'm going to see some twisted code. I know the top 6 places where folks are going to download this stuff and try to turn it in for theirs, and it's going to kill me because it doesn't take you that long to copy either of these scripts right here, and then just use the parts that we've created in your rock, paper, scissors game. We have all the pieces here. Get a name, got your counters. We have some logic. The game, the math queue could be easily changed to just game or RPS or whatever you want to call it. The play again function's already written. This is it's not that bad, but people are going to go out on a limb and really rack their brains and destroy themselves here. Don't. The whole concept of this is to reutilize code that you write. If you write a good group exercise, which you should, because I'm going to put these in the announcements, and this video's in the announcements. So when the video's done cooking, I'll post it. It takes a while. Because I have to download it, then they're upload it. It's a pain in the butt. But I'll post these two up there for you, and it should be a good time. It's not that bad. You know, it's there's not a lot of sting to functions until you start passing variables like we were, and when to return things, when not to return things. If a value in a function is going to be used somewhere else, remember, you have to return that variable, but that return value has to be stored somewhere. So you create another variable with a different name than name. First name equals get name. Get name runs, gets Timmy. Timmy's a name. Timmy's a name. This first name now holds Timmy once it's complete. That's important to grasp, because soon, in a couple weeks, you could have functions call on entire functions for a parameter. If I wanted math to get, we could do this now, but I don't want to overwhelm a lot of folks. I like showing it later on after you do your own rock, paper, scissors. But you could actually tuck get name right here and have it equal FN. So MathQ will run, it'll call on get name, it'll get your name, store it in FN, and then just pass it through the whole function. You could do that too. It's often visually unpleasing for a lot of folks at first. That's why I show it this way. And plus, it gives you practice using return, and you get to use that value somewhere else. But you can nest functions where arguments and parameters go for another function. It's very difficult to read, but if no one else is reading it, it's yours. Who cares, right? And the best code that works is the code that works. And it should be legible by at least the author and their team, right? But don't overdo it. Everything in RPS you could do with what the tools we have. Nothing wild coming out of left field, nothing bizarre. You know, it's pretty much these two group exercises put together is rock, paper, scissors. And maybe a couple of your challenges. What do you think? Any questions? Easy group tonight. Sweet. And once again, for those of you watching this video later, sorry about my email. I had a hiccup this past week with my email in Columbus State, but no worries. I got all my email back. I'll be catching up on it today and tomorrow. So if I haven't emailed you, if you emailed me this week, I'll reach out to you today or tomorrow. So no worries. These feel good though? Everybody feel all right with these? I'll take that as a yes. Sweet, I'll hang out. That's all I have to show this evening. I'll go ahead and end the video here.